Alright, this is page 3 of the Chapter 11 review worksheet, and in the first problem here, number 21, we're supposed to find the sum of this geometric series. So, if I want to first find the common ratio, if I take the second term and divide it by the first term, 10/12, that will simplify to 5/6. And if I check it out, if I multiply 10 by 5/6, I do get 56, which is the third term, so that must be correct. So the sum of this infinite geometric series, because it does appear to be an infinite series, and in fact, the common ratio is less than, it has an absolute value less than 1. So this is going to be the first term, 12 divided by 1 minus the common ratio of 5/6. So this is 12 divided by 1/6, which is 12 times 6, or 72, which is choice C. Number 22, I'm supposed to find the 200th term of this arithmetic sequence. Upon inspection, it appears that the common difference in this sequence is 3, positive 3. So the 200th term, if I start with the first term, I should have to add the common difference 199 times. So the first term is 5, and I'd be adding 199 threes to that, and that would give me 602, which is choice A. Okay, number 23, this is a sum of a convergent geometric series, meaning that this is an infinite series, and it looks like my first term here is going to be at probably 3, but let's check it out. This is probably my common ratio. So it says to start with k as 1. So if I do, I would have 3 times negative 2/3 to the 1 minus 1, or 0 power. So this would be 3 times negative 2/3 to the 0, which is just 3 times 1, or 3, for my first term. So this infinite series should be equal to the first term, which is 3, over 1 minus the common ratio, which is going to be 1 minus negative 2/3. So this is 3 divided by 1 plus 2/3, which is 3 divided by 3/3 plus 2/3, or 5/3, which is 3 times 3/5, or 9/5, which is choice B. Okay, number 24, this is like a Gauss problem. I've got just integers. I know the first and the last term. It's the sum of integers from 1 to 199 inclusive, meaning you're just counting 1, 2, 3, 4, etc., all the way up to 199. So there's going to be 199 terms in that sequence. So according to Gauss, this is going to be 199 divided by 2 times the sum of the first number in the list plus the last number in the list. So when I simplify this, I get 19,900, which is choice E. Okay, number 25, I have a geometric series, and I'm supposed to find the sum of the first 20 terms. So upon inspection, it looks like this common ratio is negative 3. And so, yeah, if you continue, you can see each term gets multiplied by negative 3, and the signs alternate. So this is a finite series of 20. So we take the first term, which in the series, which is 2, times 1 minus the common ratio, which is negative 3 to the nth, or 20th power, all over 1 minus negative 3. So when that is completely simplified, and be careful in doing this, we get negative 1,743,392,200, which is choice B. Okay, number 26, we were supposed to find the 150th term of an arithmetic sequence. So upon inspection, the common difference in this sequence, it appears that we're adding 7 to get from one term to the next. So the 150th term, if I want to start with the first term, I'll have to add 150 minus 1, or 149 common differences. So the first term is 4, and then I would add 149 sevens to that, and that would be 1047, which is choice C. Okay, number 27 is a binomial expansion. So I have to find the fifth term in the expansion of a plus 2b to the sixth. So I know in all of these I'll have to find the coefficient that goes with the fifth term, and that's going to be multiplied by the first base will be a, and those exponents are going to start at 6 and go up, start at 6 and go all the way down to 0. And then the second base will be 2b, and those exponents are going to start at 0 and go up to 6. So first I'm going to find in a sixth row expansion, a sixth row of Pascal's triangle, what the fifth term would be. So sixth row, 1, 2, 3, 4, 5. The coefficient will be 15. And a, for the fifth term, if I start with 6 and I go 6, 5, 4, 3, 2, that's going to be, the a will be raised to the second power, and then the 2b will be raised to the 6 minus 2, or fourth power, remembering that these two exponents have to add to the 6 up here. So this is going to be 15 times a squared times 2 to the fourth, which is 16b to the fourth. So when I multiply that out, I get 240 a squared b to the fourth power. And then the last one is number 28, find 3 geometric means between 48 and 1875. So let's think of 48 as the first term in a sequence. And then I'm going to put 3 geometric terms in between. So I get term 1, term 2, term 3, term 4, and then the fifth term in the list would be the 1875. So I need to figure out the common ratio, because then I will multiply that common ratio 5 minus 1, or 4 times, to get from 48 to 1875 and fill in the means. So I can look at this as I know that the fifth term in a geometric sequence, if I start with the first term, will have to be the first term multiplied by the common ratio 4 times. So in this case, 1875, the fifth term, should be equal to 48 r to the fourth. So if I divide both sides by 48, I'll get r to the fourth power will be equal to 39, and then I'll go 0.0625, 625 10,000ths. And then I want to take the fourth root of both sides, or in other words, I'm just going to raise both sides to the 1/4 power. And I'll get that the common ratio is exactly 2.5. So now I'll just take 48 and multiply it by 2.5 to get 120, and then I'll take 120 times 2.5 to get to 300, and 300 to get to 2.5 is 750, and then one last time, 750 times 2.5 is 1875. And that's it for review worksheet for Chapter 11.